Hello, this is Mr. Collier, and today we're going to be doing some exponential modeling using Geogebra. So here I have a set of data, and I'm going to enter this data into Geogebra and then use Geogebra to find an exponential regression curve. So I'm going to go to Geogebra, and actually let me just make this window smaller so I can see the data, maybe like this. Okay, now, so I might need the input now, that's good. So right now, where do I type in the data? Well, we need to go to view and make sure we have the right things in there. I think I'll put in spreadsheet, so then I can type in the data over there. I don't think I need algebra, so I can close that, and perhaps on my graph here I want some grid lines. Yes, and my t equals 0, so I think I can move this entire thing over here, something like that might be better. And my y values, or in this case the L values, go up to 74, so I think I need my y-axis to go up to about 74. So I can go to graphics and change my y max to about 70, I don't know, 75, 80 or something like that. I think that will do the trick. There we go. So that might display my graph well, and then I'll just type in my data here. So I'll put in the x values in one column called A, and my y values in the B column. Actually, I need to select A and B, and then go over to here and click create list of points. So that'll make a list of points, and we'll plot the points on here. Okay, so once we're done entering the points, I believe you can select both of the columns here and go to two variable regression analysis. Be very careful that you have the right columns in here right now. So actually I want the x values are the A column, so I want A and then B here. If I click on Analyze right now, this is backwards. This is not what I want. So I don't want that. I want this to be A and this to be B. So I click on column B here. Over here, I want to be on column A and then click on this one. And then that changes to column A. So I select, then I actually need to go to column B, and I select the second column here and it changes to column B. So this is what we want. And this looks like what we want. And you have to be very careful that this is the equation here right now. And that looks correct. You can try linear, and it doesn't really work well. Log, not really. Polynomial, it comes with a polynomial equation. That one can model it fairly well. Is there no quadratic? It doesn't seem to be. Polynomial, you can have a polynomial of size 2, so that's quadratic. You can try cubic, you can try quartic, and so forth, and try to make a new polynomial equation. We have to be very careful about exponential, because that's the one we want. But if you click exponential, you'll get actually the value of e as the base of the exponent. So we don't want exponential in this case. Actually, even though we want an exponential function, we don't use the Geogebra exponential model. We'll go to growth. And if you go to growth, you'll get the correct exponential growth equation that we're looking for. So this is y equals 4 times 1.2 to the power of x. Okay, so it's about y equals 4 times 1.2 to the power of